Hello, my dear friends. My name is Girish Udva. Today we will discuss about the basic of Slivaco Atlas TK tool. In next video, you will get the detailed information about this tool. To keep learning, please like and subscribe my channel. Slivaco Atlas TK tool. To learn Slivaco, you have to be knowledgeable for semiconductor material and their performance parameters, the electron device physics and technology, some analytical solution of the device you want to simulate. Then you have to know how an electron device is simulated numerically starting from its physical model, then its mathematical model, then its solution of the mathematical model to get the performance parameter such as IV curve of the device. Then finally the post-processing of the computational result. What is TK tool? Today, much of the development of the semiconductor devices and processes is done by computer modeling. This approach is called TCAD. The full form of the TCAD is Technology Computer Aided Design. Use of TCAD tool reduces the development cost and shorten the development time. Technology Computer Aided Design is a branch of electronic device design automation that models semiconductor fabrication and semiconductor device operation. The modeling of the fabrication term is called process TCAD, while the modeling of device operation is called device TCAD. In this presentation, we will talk about the device TCAD tool. Next slide. Process simulation. Process simulation can be done by using two processes, Victory process and Athena. Victory process is a general purpose 1D, 2D and 3D process simulator for application including etching and deposition, implantation, annealing, stress simulation. In Victory process, etching and deposition is done with geometrical model for fast structure prototyping and physical model for detailed process step analysis. Implantation is done with very fast analytical model and with very accurate Monte Carlo model. And annealing is done with comprehensive set of doping diffusion model. And stress simulation is done with stress history for stress engineering. Victory process has two modes of operation. First one is advanced structure editor and the second one is process simulator model. In the advanced structure editor mode is used for fast prototyping of 3D structures, and the process simulation mode is used for level based process simulator and more suited to detailed process-based simulation such as complex physically based etching, deposition, deposition, ion beam experiments and stress-dependent oxidation analysis. Victory process, we will discuss about this module later. Next slide. Device simulation. Device simulation can be done by using two processes. First one is Victory device and second one is Atlas 3D. Victory device enables device technology engineers to simulate the electrical, optical, chemical and thermal behavior of the semiconductor device. Victory device provides a physics-based, easy-to-use, modular and extensible platform to analyze DC, AC and time domain responses for silicon material based device in 2D and 3D dimensions. Victory device is a next generation 2D and 3D device simulator that uses an advanced tetrahedral meshing engine for fast and accurate simulation of complex 3D geometries. The capabilities of Victory process allow the characterization and optimization of semiconductor devices for a wide range of technology. For Atlas 3D, we will discuss in the next slide. Next slide, Atlas tool. What is Atlas 3D device simulator? Atlas provides physics-based simulation of the semiconductor device whose physical structure and bias condition are specified in the program. It provides a platform which helps to predict the electrical characteristics of semiconductor-based device by analyzing its DC, AC and transient response. Device 3D is a physics-based 3D device simulator for any device type and includes material properties of commonly used semiconductor material in use today. In next slide, input and output files. There are two ways to give input to Atlas. One is structure file and second one is command file. The first way is to use the automatic interface feature from deck build to transfer the input structure from Athena and dev edit to structure file and then Atlas. The second way is to create a structure by using Atlas command language, in which you have to simply write a code or on the command file. Atlas provide three types of output file: runtime output, log file and the structure file. The first type of output file is the runtime output, which gives you the progress and the error and warning messages as the simulation proceeds. And the second one is log file. The second type of output file is the log file, which stores all the terminal voltage and current from the device analysis. And the third type of output file is structure file, which stores 2D and 3D data relating to the value of solution variable which the device at a given bias point. Next one is Tawny plot. To view the result, structure file as well as log file, we used Tawny plot. Tawny plot is a graphical post-processing tool for use with all the Slivaco simulator and is an integral part of the VWF Virtual Wafer Fab interactive tools. Tawny plot can operate standalone or along with other VWF interactive tools such as deck build, Tawny plot, dev edit, mask view. In the next slide, we will talk about the structure file. Structure file provide an image of the device at a particular bias voltage. This allows to display any evaluated quantity within the device structure, from doping profile and band parameters to electron concentration and electric field. .str file can be plotted using Tawny plot. Several quantities are saved by default within the structure file, such as doping, electron concentration, potential and electric field. Additional quantity can also be specified by using the output statement, such as energy band, diagram, charge density, etc. In the next slide, we will talk about log file. Log file store the terminal characteristics calculated by Atlas. These are current and voltages at electrodes in DC simulation. In transient simulation, the time is stored. In AC simulation, the small signal frequency, the conductance and capacitance are saved. Log file can be plotted using Tawny plot. The statement log outf file name is used to obtain a log file. After the log statement, terminal characteristics obtained from the solve statement are saved into the file. Using this statement, you can save the data. Save outf file name .str is used to save the terminal characteristics. In the next slide, we will talk about deck build. What is deck build? Deck build is an interactive graphic runtime environment for developing process and device simulation into input decks. This is an extremely powerful and flexible tool that is easy to use and provides many automated features. It allows for transparent transition from one simulator to another, simulator, automatic definition of mess and mask information. Before deck build, these tasks are often required user involvement and they were extremely time consuming. In the tutorial, a brief introduction to deck build and its functionality are given. It will show you how to. In next slide, we will talk about how to start the deck build. Second is perform a basic search in the example database and load an example. Third one, execute an example. Fourth one, plot the results. And last one is quit deck build. In the next slide, we will talk about how to start deck build. To start deck build in Linux, type the following command into a terminal: deck build and end. In window, double click on the deck build shortcut. Deck build will launch and the window shown in the figure will appear. The upper portion of the window is the deck editor window, where you can either type in the syntax directly or display syntax from a loaded deck. The lower portion is the RTO, runtime output, and the side lower portion show the saved log and structure file. This will display information generated from the simulation run. The very top is a range of drop down menu and this one toolbar, which contain all the shortcuts. In the next slide, searching and loading an example. In this tutorial, a standard example is going to be used to illustrate some of the deck build features. More than 500 examples are shipped with deck build. To access the example, select File and click on the examples. As we click on the example, this will open a next slide. This will pop up the window shown in the figure. This one. The search dialog is initially populated with a classified tree of examples. This one. By entering a search string, you can search the database of example. By default, all fields are considered in the search box. This include the description, title, and section heading. In this information, the standard example, most one is first find out. As you click on the search box, you will find the number of example is related to the most one. To search for this example, most one EX01, you have to enter in the search box and then click on the enter. Example, most one EX1 is highlighted in the figure, this figure. By clicking on the load button, we'll load it into the deck build. Clicking on the another example, you will click on any of the example. When you click on the most one 0x1, the information related to this program are given below. As you click on the another, the information will be changed. You can also double click on an example to load it. All standard examples are supplied already executed. Therefore, when you load a standard example, all of the files for that examples are placed into the current working directory. This means that you do not have to execute a standard example to inspect the results. To load a pre-existing file rather than an example, you have to click on the file menu and click on the open, or you can select the file from your computer. In the next slide, deck build with most one EX01 is loaded. Deck build is incredibly flexible on how to run a deck. You can run the deck line by line, run up to the particular point, jump forward and backward, or any combination thereof. In the next slide you will see, you can run the program, run to line using a particular line. You can stop a program anywhere. You can run a program from beginning to the end also. To run the deck from top of the bottom, click on the run button on the toolbar also. The deck will immediately be executed and the RTO runtime output will be populated with the message from the simulator. In the next slide, when a deck is executed any program, it generates a number of files such as structure files and log files. These files are displayed using tonyplot. Whenever a tonyplot recognizes file name .str and .log appears in the deck or the RTO, you can also see the structure using RTO. Using editor window, you can also show the structure file and log file from this saved directory. You can plot the structure from the RTO also. You can right click the file name to plot the file. Figure show the menu that opens when you right click on the valid file name. Clicking on the plot will cause tonyplot to launch and display the specified file. You can also launch the tonyplot from the deck build by clicking on this option, this tonyplot icon, or you can open the tonyplot, click on the tool and click on the tonyplot option. This means you can run the tonyplot from any option, from the RTO, from this icon, from clicking on the tool and click on the tonyplot. There is a number of options to run the tonyplot. In the next slide, how to quitting deck build. Simple. You have to click on the file option in the top right hand corner. A certain number of files are automatically generated during a simulation run. These files are saved in a hidden folder in your current working directory. After the example MOS1 EX01 has been run, deck build will ask you to confirm if these files will be kept or removed. For exit, you have to simply click on the file option and then click on the exit option. You can exit from the deck build. Okay, my dear friend, that is it for today. For more information how to run a program in Slivaco, please stay tuned. Thank you.